Let me see what I can do, okay?
Okay, thanks.
Okay, I'm sending new link. All right. Can you all try and see whether it works this time?
We made permission.
Hmm?
You need permission.
You need
Access.
permission? Okay, have you asked for permission?
Oh
Okay,
wait,
I'm not
maybe I'm not
restricting it.
using
I'm
the
open anyone. Okay, anyone with link.
notifications.
Anyone with link. Okay, done.
Okay, yeah, we can see it now. Thanks.
Okay, great. Okay, so what are we going to do today? First things, your test. I've only marked 2 questions. There are about 6 questions. I've only marked 2 questions, and I marked them not according to the questions that you answer, but according to what is in my master's list. So what I've done is I've marked the secant questions and the Newton-Raphson question. It's the same function.
Yeah, doctor. You
I
share
have
us the
already
link
given
to edit.
access.
Yeah.
Oh no, well, don't edit lah. Just put in your
No,
name.
I mean we can't do responses as well.
You
But we're actually
can't.
getting the link to the Google form itself.
You still cannot link. I thought I've given access and
No,
permission.
what I mean is that you're given access for us to edit the Google form, not
Okay.
to fill in the
Let's
Google
see.
form.
Let's see. Okay. Let's see what I've done. Okay, what I'm going to do is, I don't know why. I thought I have already changed the access. Okay. You should be able to edit this. Okay, try again. Success. I'm using an old form, but you should be able to add on top of it.
Doctor,
Even
you're
though,
actually sharing the administrator's version of the Google form.
mm, it,
That's what I
mm,
meant. Sorry.
oh, I see. Okay, it's all right. It's all right. It doesn't matter. You're not going to change anything, right?
Yeah. So we just submitted.
Yeah. You just submit. Yeah. Don't change anything. It's just for reference. Okay. Nobody's going to check your attendance actually, but we need it for reference. Okay. As I was saying, the test. Okay, some of you did not submit your answers, either through Spectrum, or I've given you a chance to email or to submit the answers through WhatsApp. Well, there were a few who did neither. You did not submit through Spectrum, you did not submit through WhatsApp, you did not email me the answers. So what do I do with all this? What do you think these people should get? Class? I am not a mind reader. You don't submit your answers, I will not be able to mark them. Okay? So you will be marked as not submitted, or you get 0. Okay? If you don't submit your answers through Spectrum or email, I'm giving you a chance. This is the last time. For test 2, it would have been the last time that you can submit your answers through email or WhatsApp. For the next tests, no emails, no WhatsApp. If you don't submit through Spectrum, that's it then. You don't get anything. But even then, some of you did not submit through emails or WhatsApp. So there's nothing I can do to help you all. There were a few. I think you probably know who you are. Okay, were there problems trying to submit through Spectrum? Class? Class?
No problems.
No problems. So why is it that you all did not submit through Spectrum? You're supposed to submit every question. If you leave it until the end, then you've got this problem. If you can't submit on time, then you won't submit for all. But if you do it with every question, then at least it's just possibly the last question that you don't submit. Okay, you have to keep to the time allocated. 1.5 hours for that test was more than enough. It was in fact very, very generous. Was it a difficult test? No answer?
It was okay.
It is not difficult, yes. Was it an easy test? It was okay, all right. So was the time allocated enough? Writing matrices takes time. It's just a matter of writing. I'm not asking you to type them in. Just write. If you have to type, then it will take a long time typing matrices in. But if you're just writing on your paper, it shouldn't take any longer than writing any other answers. Okay, well, you just have to practice keeping to time. This is an open book test. You've got everything that you need to refer to. Okay, so there should be no reason for you all to get A actually. Right element operation take time. Everything takes time. Okay, everything takes time. Sometimes well, that's what practices are for. When you practice, you don't miscalculate. Okay, from what I can see, exporting the images takes time. What do you mean by, like I said, do it for every question? So you are given what, 90 minutes? 90 divided by 6 was about 15 minutes. 10 minutes for you to do the question, 5 minutes for you to submit for each question. Compile images to PDF takes time. It doesn't take that much time actually. 5 minutes to do everything, it should be more than enough. Scanning and transfer everything to PC takes time. Well, everything takes time. Sometimes need to find correct angle to get nice picture. I don't expect a nice picture, I just expect a clear picture. Oh, by the way, there was one script that I marked which was written in pencil. Written in pencil coupled with scanning, it caused a very blurry image. Okay? Now, when it's blurry, it strains our eyes, and we're not going to treat you very kindly when, under difficult circumstances. Okay, so please don't write in pencil. It takes 4 minutes for each question to be submitted. My internet bandwidth needs more than 1 minute to upload one question, actually. Well, you're given 5 minutes. So more than 1 minute should be more than enough. Lighting at home isn't good. Is there any way you can do, is there anything you can do to improve the lighting? Don't you have a study lamp? I don't think it's very expensive to get a study lamp. Okay, so many excuses in submitting the questions, but you don't tell me that you don't tell me the positive side, that you've got all the formula given uh, next to you, that you've got all the steps on how to carry out the calculation next to you, that you can look at previous questions in order to carry out the calculation for this question. You can base it on previous questions. You can look at your tutorials to actually remind you on how to do the questions. You don't tell me all this, do you? Silence? These are all the plus points. Why aren't you telling me the plus points? Nobody wants to talk about the plus points. Yes, you agree. Okay, you have to be positive. There are plus points. Well, in fact, the plus points are more than the negative points. When have you ever sit for tests in which you can actually look at how to do the test questions in your notes? Have you ever had that opportunity before? Yes? No? Nobody wants to answer the question. All right, I understand the problems. I also know the advantages. Okay, so in future, try and keep to the allocated time. Okay, class? All right. Okay. All right, so what are we going to do today? Today's class is going to be a very short class, but I have got some exercises for you to do online. The exercises are in Spectrum. I've not uploaded any notes in Microsoft Teams lately, but the notes in Spectrum is up to date. The tutorials in Spectrum are up to date, and there is also an exercise for you to do in Spectrum. The exercise is called a revision paper, but it's actually exercise for today's work. All right. As I say, the class for today's class will be very short, but please use the time wisely and carry out the exercise I've given you. Okay, so what are we going to do today? Can you see my screen? Say something because I'm not looking at the chat.
Yes,
Yes,
doctor.
doctor.
Okay, what does it say?
Numerical differentiation.
Okay, right. Now, what is numerical differentiation? There are algorithms for you to estimate. Yeah, this is an estimation of the derivation. Okay, to estimate the derivative of a mathematical function using values of the function and some other knowledge. Okay, it is an approximation. It is an estimation. Just like your interpolation, just like your function approximation, this is also an estimation. Okay, the term numerical always means it is an estimation. We are not going to directly differentiate, but we are going to estimate how the differentiation will be. Okay, so what do we do? How do we do it? We use what is called a forward difference formula, a backward difference formula, and a central difference formula. I am sure we have used this in the past before. If not in first year, then at least in second year, in the 2002 class. How many of you are not in my 2002 class?
Which class?
The WID 2002. Are there anyone in this class who was not from the WID, who was not in my WID 2002 class?
Me.
Only you.
Yes.
There is Chanel, is it?
Nabil.
Nabil. Okay, so you are the only one, yeah? All right.
Yes.
Okay, the rest of you have gone through my class, so you should know what I'm talking about when I say forward difference formula, backward difference formula, and central difference formula. But if you don't, today's lesson will actually give you a revision of it. Okay. Now, a function is differentiable, okay, if it is continuous, okay, and if it has a limit. All right, now we write it as the limit as h approaches 0, the function c plus h minus the function of c divided by h. What it means is that the function at a particular value, taking that value as close as possible to it. Okay, if you have a curve, remember your approximation. Can you see my camera? Can you see the whiteboard camera? Somehow I can't seem to change the camera setting. Okay, let's try again. Audio seems to be all right, but my camera is not working. There you go. Okay. Now can you see the whiteboard?
Yes,
Yes.
doctor.
Okay. Right. Now remember when we were doing differentiation? Okay. Okay. If this is your X or C, it can be X, it can be C, it can be anything. Okay. And if this is H, okay. Now you can either go from the left or from the right. You all can see the board clearly?
Yes, doctor.
Yes?
Yes, doctor.
Okay. This would be X plus H, right? So if you take f of X plus H minus f of X over H, as H approaches 0. Now, this formula that we have here is one of the most important formula that you can think of. Okay? There is nothing more important than that formula. Okay, so what is that formula there? Anyone can guess? The limit of a function as you take an interval, which is h, and you try to make the interval as small as possible. Or rather, you access the function at one point, and then you access the function at another point, and then you take the limits divided by the interval. What are we doing here? What is this same as? Gradient, okay. Gradient of what? Gradient of what? Yes, it's a gradient, I agree. But it's not just any gradient. Rate of change in gradient. Okay, not too bad. Don't you recognize, yeah, gradient descent? Okay, gradient is actually a descent, isn't it? Gradient of the function in point X. Okay, what are we talking here? When we take a curve and you find the gradient of a curve, so what are we talking about? Exactly. This, if we go back to the whiteboard, if we go back to the whiteboard, this is what is known as f prime x, right? And what is f prime x? The differentiation of x. This is by nature the definition of differentiation. Okay, this is the definition of differentiation. And in order for a function to be differentiable, what must it be?
Continuous.
It needs to be continuous. Yes. What else?
Limit to the left must be equal to limit to the right.
Okay. It must have a limit at the point in question. And if it has a limit at that particular point, this means that limit from the left and limit from the right is the same. Or, well, they exist and they are the same. Okay, the limit exists at that point, meaning that the left limit and the right limit are the same. and the function is continuous. Okay, that is the definition of differentiation. Okay, let's go back to my notes then. Okay, and this is what we have on the screen. Can you see the screen now? Say something, class. Can you see the screen?
Yes, doctor.
Yes, doctor.
Okay.
Yes, doctor.
All right. Okay, so a differentiable function is a function that can be approximated locally by a linear function. So suppose you have the function of a to ab which maps onto r. What is r? R will be real number. And c is in between a and b. Then the function f is differentiable at c. That means f prime c exists if you can find the limit of f c plus h minus f of c over h. Okay, and is this any different from what I have written earlier? There are many ways you can write it. Okay, it's just a matter of writing. So please be aware of the different ways you can write a function which is differentiable at a particular point. You can say c plus h, you can say x plus h, you can even say a minus b, and so on. Okay? All right? Now, the domain of f prime c is the set of all the points in AB for which this limit exists. And if this limit exists, we say that f is differentiable on the interval AB. Okay, graphically, this definition says that the derivative of f at c is the slope. Remember, you all use the gradient, the term gradient. What is gradient? Gradient is actually a slope. But I was looking for this, the tangent line. None of you mentioned the tangent line. Okay, when we are talking about dy dx, or when we're talking about differentiation, we are talking about the tangent line at a point on the slope. Okay, so please be aware of that. All right, class?
Yes, doctor.
Can you still see the screen?
I see the calendar, doctor.
Oh, it's gone back to calendar. Okay, never mind. I will go back to the screen. I'll try and go back to the screen. Okay, can you see the screen now?
Yes, doctor.
Okay, so graphically, as I said, this is the derivative of f at c, and it is the slope of y at fx, where x is equal to c. And as we have mentioned, it is the limit as h approaches 0 for the lines through c, f of c, c plus h, and f c plus h. Okay, so this is how we would write it. Remember I said there are many ways we can write it. This is another way to write it. Okay, now the ratio, can you see what I'm pointing at? Can you see my cursor?
Yes.
Okay, can you see what I'm pointing at the ratio? Yes?
Yes.
Okay,
Yes.
now the numerator and the denominator is undefined, while the ratio is undefined when?
When it's 0.
When the denominator is 0. When is the denominator 0? You all know numerator and denominators, don't you? Yes? No? Don't know?
Yes.
Yes.
Okay, what's a numerator? If you have P over Q, what's a numerator? Class?
P, the top part.
And what is the denominator? I can't see your chatbot. When I'm presenting, I
Q.
can't see your chatbot.
Q, doctor.
Q, right? Okay. So now, when the denominator is 0, it is undefined. Why? Why
We
is
can't
it
divide
undefined?
any number by 0. It's
You
undefined.
cannot have division by 0. Okay? So when it is 0, what does that mean? When is it 0? When will this be 0?
X and C here are if they're equal.
When x is equal to c, yes. Okay, so it is not defined when x is equal to c, but it does not have to be defined in order for the limit to exist as x approaches c. Okay, do you know what I mean? It is not the same as x equals to c, but it is as close as possible to c. X will get as close as possible to c, and x will have a limit as it approaches c. That is what it means. Okay? All right. So, like continuity, differentiability is a local property. So we say that the differentiability of a function is f is at c, and the value of the derivative depends on the value of f in the neighborhood of c. Okay? Okay, so you can read this on your own, which is actually is a little bit of mathematical information. Now, what is important is that if a function is differentiable, it is also continuous. But if a function is continuous, it is not necessarily differentiable. Okay? Please know the difference. All right. Next, we are going to talk about a forward difference formula. Nothing different, the same thing that we have on the board. Okay, so the limit as h approaches 0, f of x naught plus h minus fx naught over h is, as I have mentioned earlier and as I have written on the whiteboard earlier, is f prime x naught. Okay, and this is what we call the derivative of x at the point x naught. And this is a 2-point forward difference formula. Okay, it's just a name. The name is forward difference. And we are looking at the derivative with respect to 2 points. So it is a 2-point formula. So far, so good?
Yes, doctor.
Okay. Now, fx plus h can actually be expanded using the Taylor's expansion. Now, you are all very familiar with this. We've used this over and over again from first year, second year, and even third year earlier. We have put down Taylor's formula. If we take this, can you see this? Can you see this on the right-hand side of the Taylor's expansion?
Yes.
Okay, the second term, and you do a bit of mathematical manipulation. Class, we do a bit of mathematical manipulation. Can you get equation 1?
Yes.
Okay, what have we done here? Now, our focus is on f prime, right? So we take the second term. We want the second term, so we want it on our left-hand side. Okay, or it can be on your right-hand side. It doesn't matter. We just want it on one side of the equality sign. Okay, so for that reason, we bring this over to the other side. So you get fx plus h minus fx, right? And then you will get h f prime x plus all this blah, 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 blah on the right. Can you see that? Yes? No? Yeah?
Yes.
But we don't want h
Yeah.
f prime x. So we divide fx plus h minus fx with h. So then you will get only f prime x, right? And this will just be h over 2, and so on. Okay? So with a bit of mathematical manipulation, you get this formula. Okay?
Okay.
Right? So that is what we want to represent our function f. We are representing our derivative by 2 points. What are the 2 points? X plus h and x. Okay, we've got a suffix 2 here. Can you see that? Now, the suffix 2 means that we are using 2 points to define our derivative. Okay, it is a derivative because that's what we got earlier. And we have also seen why this is h. Okay, now the error is actually dominated by order h. You all know your big O notation, right? Computer science students?
Yes, doctor.
Okay, so this approximation is called the 2-point forward difference formula. And the error is actually in the order of h. Okay, but if we go on further, the order could be different. Okay, so far so good? Okay, now I've got an example. Using the example that we have, using the formula that we have, which is the forward difference formula, and a step size of h equals to 0.2, can we find f prime of 2.0? All right, I'd like you all to try this. I know I've got the answers here, but it's only partial. Can you try this on your own? I give you 2 or 3 minutes to do it. The first person who's found the answer, just say, yes, you've got the answer. It's now 1:43. By 1:45, we'll check the answer. Simple equation and simple derivative. Okay, done? Done, class? Still working? Are you all still working? What's taking you all so long? Class? Can you find the answer? Is this a matter of calculating that?
Yeah, found the answer, doctor.
Find the answer. What's the answer? What's the answer?
It's same as you.
Same as?
1 second, doctor.
Okay. Right.
It's negative 0.0045.
Negative 0.045541. Okay. Now, imagine if you have to find the differentiation of this and you're not using a difference formula. Okay? So what do you need to do? You probably will have to use function of a function and the product rule. Agreed?
Yes.
Okay, so the difference formula or numerical differentiation makes calculation, makes finding derivatives easily. All right? So this is the table. Now, the question does not say to leave your answer in how many decimal points. So you can leave it in whichever way you find. Now, we are actually looking at 5 decimal points here, which actually reminds me of your test. In your test, all your answers were supposed to be in 3 decimal points. I have had more than 20 students giving me answers which are not following the instruction. Okay, so in future, please don't do that. I cut off marks when you don't follow instruction. Okay? And you are supposed to follow the 3 decimal point for every step of the question. Okay, now another formula is the backward difference formula. Now, with the forward difference formula, we go fx plus h minus fx. But with the backward difference formula, it is the other way around. We take fx minus fx minus h. You are actually just replacing the h with a minus h, okay? Where h is a positive value. Okay, and in this case, you get the backward difference formula, which is still a 2-point formula. Okay, so what if we want to find f prime of 2.0 using the backward difference formula? What would you get? Can you all try that? Using the backward difference formula now, h is still 0.2. Okay, can you find it? Yes, no, don't know. How would the equation look like? F prime 2.0 will be f of silent. Nobody answering. Anyone wants to try? What would this formula look like? This part here. Can you see what I'm pointing at? This is the forward difference formula. So using the backward difference formula, what would this ratio be? You don't have to work it out yet. Just give me in terms of f. Class, are you still with me? Where is everyone gone to? You having your lunch or something?
It would be f 2.0 minus f 1.8 upon 2.0. Oh, 0.2.
F of 2.0 minus f of 1.8 divided by 0.2. Exactly, right? Okay, which is what Yes, this is what I have here. Okay, it's exactly the same thing, but this is now using the backward difference formula. And what is the answer that we get? This. So you notice using a forward difference formula and a backward difference formula, you get different answers. All right? So far, so good, class? Can we go on?
Yes, doctor.
Okay. Now, we want to look at the central difference formula, but the central difference formula is actually using 3 points. Okay, so now the function actually can be evaluated if we just use 2 points. Okay, but using 2 points may not give you the best value or the most accurate value. So we now want to look at how we can use 3 points. Okay, let's see if we can find figure 1. Where is figure? This is figure 1. So if this is x naught, if we use 3 points, it would be x naught minus h, x naught, and x naught plus h. Okay, these are the 3 points. If we use more points, 1, 2, 3, 4, 5. If we include another h, then we are using 5 points. We can go on and on and on, use as many points as we want. And we will see later how we can find the formula using more points. Okay, but first we are going to look at the central difference formula. Okay, now the central difference formula is this. Do you know how to get this? Remember your equation 1? Where is equation 1? The forward difference formula. This is your forward difference formula. Okay, this is not equation 1. This is equation 1. Well, it's the same. Okay, this is the forward difference formula. And then you have your backward difference formula. Okay, if you add the 2 up, can you do that? Add the 2 up. You can ignore the error, yeah? The order H. Just ignore the error. Add the 2 up and what do you get?
The fx will be cancelled, both of them. So we are
Fx
just
cancelled, yes, because you have in equation 1 minus fx, in equation 2 plus fx. So when you add the 2 up, fx is cancelled. But what do you get?
fx plus h minus fx minus h
Over?
upon h,
Which is equal to?
f dash x.
Yeah, not quite right. You're adding 1 and 2. So what do you get here?
Oh, f the double differential.
No, no, no,
Huh?
no.
F prime to x.
2f
To
prime
F prime
x.
x.
Yes.
Yeah.
You get 2f prime x because you're adding 1 and 2. Okay, but we don't want 2f prime x. We only want f prime x. So your 2, where does it go? Your 2 comes
Goes to
here,
the
right?
right.
The denominator.
Right
Okay,
hand side.
it comes here. And that is what you get here. This is your formula. Can you see that?
Yes, doctor.
Okay, so what happens if we use the same example but now using the central difference formula. Okay? All right, at 2.0. Okay, now same example using the central difference formula. I want you all to work, all of you. Okay, right, at this stage, can you see my cursor? At this stage, what would you have?
Negative 0.7?
I just want this first before you get the final answer. At this stage, can you see where I'm pointing at?
F of 2.2 minus F of 1.8.
F of?
F of 2.2 minus F of 1.8 over 0.4.
Okay, good. Very good. Okay. And this is what we have here, right? Okay. And your answer is this. Is that what you all got? Yeah?
Yes.
Okay, great. Okay. Now, error analysis. Okay, so remember we said that when we do this, when we use what formula is this? What's the name for it? It's a 2-point formula, but what is the name?
Forward
different formula, right? Okay, it is the forward different formula. Then the dominating error is actually order of h. Okay, now if the second derivative is very close to 0, then this a 2-point formula can be used to approximate the derivative. Okay, so if we have a function like this, a plus bx squared, using the formula we get 2bx plus 2bh if we use the formula. Well, you know, if you differentiate this, okay, if you differentiate this, the exact answer is actually 2bx. So unless our h is very, very small and b is also not too large, then we are actually approaching the exact answer. Or we could approach the exact answer if we choose h is which is very small. But however, the subtraction fx minus h can actually give rise to round off errors and it will lead to a loss of precision. And for that reason, we may want to use other formulas, 3-point formula. Okay, now how do we use 3-point formula? The central difference formula is one of it, but we may want to use a forward difference formula or a backward difference formula, but can we do that with 3 points? What do you think? Do you all think that we can use a forward difference formula or a backward difference formula using 3 points? Okay, let's see now. You all know that fx plus h, using Taylor's, you will get this. And for fx minus h, you will get the second line. Okay? Now, what happens if we add this? Okay, this is actually f plus h and f minus h, the same formula that we have here. Okay, there's no difference here. Can you see that? And this is in order of h4. Now, if we do a bit of manipulation again, okay, we come to this. Okay, can you see that? So we can actually write this in order of h cubed. Now, if h is very small, h cubed will be a lot smaller than h. So this is actually a far superior, so to say, or a more precise formula. All right, and it is in order h cubed. Okay, so again, we still use the suffix 3 because we're using 3 points and the dominating error is now in h cubed. Or if we want in order h squared, all right. So if we want in order h squared, it will be here. We will stop here. If we want in order h4, we will need to go on another step, right? So it is here. Okay, class? Class, do you know what I'm talking about?
Yes, doctor.
Okay, good. Okay, now what if we want a higher derivative? That means instead of f prime x, we want f2x or f3x. That means the d2f dx squared or d3f dx cubed. Do you think we can do that using a 3-point formula? Okay, let's see now. Okay, this is the formula we had earlier. Yes? Yes or no?
Yes.
Okay, now where is our second derivative? It's on the right-hand side of the equation, isn't it? Yes?
Yes.
Okay, now what if we want this second derivative? What happens to your formula? you want a second derivative. What happens to this formula that we have here on the screen?
We divide the left-hand side by h squared.
But you still have order H4, right? You can bring the order H4 to the left. It will still be order H4. It doesn't matter whether this is plus or minus. You just put it as plus because all we're talking about is order of H4. Okay? Right? So you can actually define the second derivative, and it is fh minus 2f plus f of minus h over h squared, right? And which is this. So this is your central 3-point difference. And similarly, you can find the forward 3-point difference and the backward 3-point difference for the second derivative. In fact, you can find your any derivative using however many points, and this is what we're going to do next, using a method which is known as the method of undetermined coefficient. Have you heard of it? Has anyone heard of the method of undetermined coefficient? Yes? Nobody has heard of the method. Class? Hello?
No, doctor.
Seems like we haven't, Doctor.
Hmm?
Seems like we haven't heard of this term.
You haven't. Okay. All right. So if you haven't, let's look at it, right? Okay, before you do that, let's just do one simple example. Outward distance of an object is given as a function of time. Determine the value of acceleration at t equals to 1.75 using the second derivative approximation formula. Now we can use central, we can use forward, you can use backward. I think I'm giving all. Okay? All right. Do you think you can do this on your own? Or you think you can do it now? Just give an answer. Use the central one first. At least we go through the central. Okay, I'll show you the formula. Right? Okay, that's the formula you want to use. And this is the equation. What is acceleration? What is acceleration? If distance is d, or s, sorry, if distance is s and time is t, what is acceleration? If you denote acceleration with an O, with an A. Sorry, Adriana, that's not the right answer. What is acceleration? Come on, you all learned this in Form 5. Yes,
Distance over time.
It is dv over dt. What is v? What is v?
Distance
Speed
over
of change.
time.
ds over dt. So acceleration is actually d2s over dt squared, right? Okay, now can you do this using the central difference formula? And just these values that you have here. Can you come out with the equation first? If you cannot solve it yet, can you come out? Change this into a mathematical model. Okay, what is the formula? It is central, yeah? I mentioned central, so it is f of x plus h minus f of x plus f of x minus h over h squared. So what do we do? Class? Everyone struggling? Okay. Right. Sorry, this should be S, yeah? Can you see the formula? Right. Did you get this part at least? Yes or no? Class. This should be S, yeah, not F. Can you see that? It should be S. Okay, so we have S T plus H minus 2S T plus S T minus H over H squared. Okay, what is T? We want T as 1.75. So you know that this should be 1.75, right? So what should this be? And what should this be?
Doctor, what is our hash here?
That's what you have to figure out.
Oh.
That's what I'm asking. What is H? Okay. Look at this. We must pick H such that 1.75 minus H must be the same as 2.5 minus H. Okay, because we have only 1.75 and 2.5 and 1.0, right? These are the three values we have, which is as close as possible to 1.75. Can you see this? It's from this table. Okay? It's from this table, isn't it? We have 1.0, we have 1.7, we have 2.5. But we don't want 1.7, we don't want 2.5. we want 1.75. So what should your H be such that it S plus H will be 2.5, S minus H will be 1.7. What is it? When
0.75.
1.75. What is it? What do we get? H is? Can we use 1.75? Okay. If we use 1.7, the difference between 1.75 and 1.7 is 0.05, right? Agreed? Then you
Yes.
will need something which is higher by 0.05. That means you will need 1.8. Do we have 1.8 here?
No.
No. So we cannot use 1.7. Okay, now if we use 1.0, what is the difference between T and 1.0?
0.75.
0.75. What is the difference between 1.7 and 1.75? We've already mentioned 0.05. No, we ignore this. What is the difference between 2.5 and 1.75?
0.75.
0.75. So these are the two values you can use. This would be your T minus H, and this will be your T plus H. And what is your H? 0.75. Okay, now let's see. So we get, yes, this is what we get. Okay, which gives us a value of 60.44. Now this is actually not very accurate. Do you know why? Can anyone tell me why this would not have been a very accurate answer? Nobody's going to try?
Because it's an acceleration.
No. Think. What did we say earlier about H? What must H be? You all need to think a little bit. So, what must H be? Why is this not very accurate? Because the value of H is 0.75, which is quite big, almost 1, right? It is almost 1, so it's not a very accurate answer. Okay, now going back to that table we have earlier. It would have been good if we could use 1.0 and 1.8, right? Then your H would only be 0.05. But since 1.8 is not in the table, we are stuck with a value or with an answer which is not very accurate. Okay, but that is to the best of our ability given the values, the data that we were given. All right, is that clear? Class? Is that clear?
Yes, doctor.
Okay, do you all need a break or can we go on with the method of undetermined coefficient? For this, I need to go to the whiteboard. Class, are you all still with me?
Yes.
Okay, now. Do you all need a break or can I continue? Yes or no?
Break, doctor.
You need a break. Okay. In that case, we'll have a 5 minutes break and I'll continue later. Okay?
Thank you.
Okay, now with the method of undetermined coefficient, we will be looking at 5 points. Okay, we'll continue in a short while. All right, I'm back. Can you all see? Can you all see the whiteboard?
Yes, doctor.
Okay, we are going to find the derivative of x based on 5 points. Okay, we've seen for 2 points, we've seen for 3 points, and as I've mentioned earlier, we can do it for as how many points we like. All right, we are going to see for 5 points. These points are x plus 2h, x plus h, x, x minus h, and x minus 2h. Okay, first thing that we do is we find the Taylor's approximation for this. Now, as we all know, the approximation for this would be f of x plus, this is 2h, yeah? So 2h f prime x plus 2h squared over 2 factorial f2x plus 2h cubed over 3 factorial f3x. Right? Agreed? Yes or no? Say something.
Agree, doctor.
Okay. Now, the expansion for f x minus 2h would be the same as this, except that this will be negative, and this will be negative, and so on. Okay, so what I'm going to do is I'm going to put minus here, right? And minus here, every alternate ones, minus here. Okay? X, expansion of f, x plus h will be f of x plus h f prime x plus h squared over 2 factorial f2x plus h cubed over 3 factorial f3x and so on. And for expansion of f of x minus h would be the same as this, except that alternate terms will be negative. So we put minus sign here, minus sign here, minus sign here, and so on. So far, so good? It's just Taylor's expansion. Okay? Good?
Good.
Can't hear you. Mara, you're saying something, but I can't hear you.
I said all good, doctor.
Okay, so what we are going to say is, we say that f prime x is equal to a f x plus 2h, okay, plus b f x plus h plus c f of x plus d f of x minus h plus e f of x minus 2h. Why do we say this? Because we want the derivative of x to be in terms of these 5 points. Okay, these are the 5 points which we found the expansion earlier. Okay, these are the points. Why do we put A, B, C, D, E? Because we don't know what these values are, and we're going to find what these values are. Okay? All right, class? Now, we've got this, and we've got this, x. Don't forget x. Okay, now we can write this in terms of A, okay, f x plus, this, the expansion here. Okay, expansion 1 and plus or minus, right? This is the expansion 1 plus, and this is expansion 1 minus, and this is expansion 2. Okay, this is expansion 2 plus, and this is expansion 2 minus. Everyone agrees? Yes? No? Okay, Adriana, I don't know what you said. Okay, let me see what she said. Okay, all right. So far, so good. Now, looking at the right-hand side and the left-hand side, you can say that f prime x is equal to f of x a, because you've got here a fx plus 2h, you will have an a here, right? Fx, and you will also have it for b. B also have f of x. Okay, just imagine this is a, so you put a here, and b also, and e also, because e is the negative sign, and then this is b, so you will have b here, okay, and d as well. All right, and this is c. Okay, do you know what I'm doing, class? Yes, good. The reason why I'm doing it like this is because we don't have enough space. Now, do you know what I'm doing? Or do you want me to go step by step, write everything down? If that is the case, I will have to erase the Taylor expansion. Say something. If you don't say anything, I don't know what you want. All right. One you. Hello.
Yeah.
What would you like me to do? Are you okay with what I'm explaining so far, or do you want me to go step by step?
I need a little bit of time to digest this kind of stuff.
Huh? You're stuck.
Yeah.
You're already stuck. Okay.
I can see the relevance to it.
Everyone knows, right? Okay. Everyone knows the Taylor's expansion. Can I erase the Taylor's expansion?
Yes.
Yes,
Doctor. Right. So we erase the Taylor's expansion. Okay, remember I said that we are going to write f prime x as a of f x plus 2h plus b f x plus h plus c f of x plus d f x minus h plus e f of x minus 2h. Why do we write it like this? Because we want our derivative to be in terms of these 5 points. And then we don't know what the coefficients are, and we will find out what the coefficients are in a short while. Okay, we need to solve for A, B, C, D, and E. Okay, now what we're going to do is we are going to expand this. So we have A, F, X plus 2H, F prime X plus 2H squared over 2 factorial F2X plus so on. That is your first part, your A part. Plus B f of x plus h f prime x plus h squared over 2 factorial f2x plus dot dot dot. You can go on and on actually, depending on the question. Plus c, what is c? F of x. What's the expansion of f of x? It's still f of x. You can't expand it anymore. Plus e, plus d. D f of x minus h f prime x plus h squared over 2 factorial f2x plus dot dot dot. Okay, and then plus e f of x excuse me, minus 2h f prime x plus 2h squared over 2 factorial f2x plus dot dot dot. Okay, now this f prime x is equal to all this. Okay, you add all this up. Okay, so what you will get is f prime x equal to a of fx plus b of fx plus c of fx plus d of fx plus e of fx. Agree?
Yes.
Okay,
Yes,
so
yes.
then you have f of x a plus b plus c plus d plus e, right? Plus f prime x, where is it? F prime x, f prime x, f prime x, f prime x. Okay, so what is it? You should have actually h, right? H is actually h f prime x. So we put h f prime x. Then what do you get? 2h f prime x a. So 2a plus b minus d minus 2e. Agreed? Yes.
Yes, doctor.
And then plus h squared over 2 factorial y. H squared over 2 factorial. Even here is h squared over 2 factorial, but we'll just take this part here. This part we bring inside. So what do we get?
2e.
H squared
4a.
4, right? 4a
Yes, 4.
plus 2b minus d. Minus d or plus d? Plus d. Plus d plus 4e. Okay, so now 1, 2, 3. It is not complete. We need 5 equations. Do you know why we need 5 equations? Because we've got 5 unknowns. So what it is we ended this too soon. So we're going to expand this further. We have 2h to the power of 3 cubed f3x plus 2h to the power of 4 factorial f4x plus 2h to the power of 5 factorial f5x. And you do the same with all the others. Okay, so this will give you, the next one will be h cubed 3 factorial. Then what do we get? H cubed over 3 factorial, 2 to the power of 3 is 8. So you get 8a. And then h cubed b. This will be h cubed. Okay, that's fine. That's b plus b, and d h cubed over 3 factorial. H cubed will be negative d, and e will be h cubed over 2 to the power of 3 also. So minus 8e. Can you see that? Now you've got 1, 2, 3, 4, which is still not enough. We need one more. Okay, and that one will be h4 over 4 factorial. h4 over 4, h4 over 4 factorial, 2 to the power of 4, which is 16a. h4 over 4 factorial plus b plus d minus 16, no, still positive, e. And 4. And this is F2, this is F3. Okay, so far so good, class? Yes, no? It's just a matter of expanding all this using the Taylor's expansion. Okay?
Doctor.
All right?
Doctor, we can't
Now,
see the whole
what
board.
we're going to look at the left-hand side of this equation and the right-hand side of this equation. Looking at the left-hand side and the right-hand side, equating, okay? Equating left and right. What can you say about this? What can you say about this? Does this term exist on the left? This is the left-hand side of your equation, and this is the right-hand side of your equation. All this up till here, and this. Okay? Looking at the left and the right, does this exist on the left-hand side of the equation? Just compare left and right. Does f of x of something, does it exist on the left-hand side of the equation? What is on the left-hand side of the equation?
F prime x.
What is on the right-hand side of the equation?
There are 5 terms. The first one is f of x.
The first
And
one is f
some
of x.
coefficient.
Does the term involving f of x exist on the left-hand side of the equation?
Does not.
It does not, right? And the only way we can say that it does not appear on the left is by making this 0, right? And the only way we can make this 0 is when we equate A plus B plus C plus D plus E is 0. And you get 1. What about f prime x? Does it exist on the left?
Yes.
Yes.
Yes. So we say that h 2a plus b minus d minus 2e is the same as, looking at coefficient, it is the same as
1.
1.
1.
So this is 2. How can you see? All right. Okay. Now looking at the third one, we've got when it's 0, I will not bother with the H. Okay. We have 4A plus B plus D plus 4E equals to
0.
0. So this is the third one. Now, next, you have 8A plus B minus D minus 8E equal 0. And this is the fourth one. And finally, we have 16A plus B plus D plus 16E equal
0 again.
Okay, so you have 5 equations and 5 variables. Can you solve this?
Can.
How do we solve this?
Gaussian elimination.
Gaussian. The easiest way would be to use Gaussian. Okay, so far so good. Can I erase and go on to Gaussian?
Can.
Can. Okay. Right. So far so good, right? Okay. Now, barring mistakes, there could be what do you call it? Careless mistakes there. I'm not sure, but let's see whether what we've done is correct. Okay. Okay, this is what we have. Isn't this what we did just now? Class? Right?
Yes,
About right?
Yes, doctor.
Yeah. The arrangement. This is the arrangement. You see? The reason why mine is positive and is the other way around in the notes because of my arrangement. Remember what the arrangement was. Okay, this is our arrangement. Okay, in the notes, the arrangement was the negative is here, the x minus 2h is here. So it doesn't matter how you arrange it. Is that clear? Yes, no, don't know?
Yes.
Yes?
Clear.
Okay, great. Next, and this is our in matrix form, 1 over h. Why is it 1 over h? Do you know why? Because you've got a h here, and this is equal to 1, so you bring your h over. All right, class?
Yes, doctor.
And then you use row operations to solve this. Now you've done enough row operations to be able to solve this. Do you all agree? Okay?
Yes.
Right, let's look. Right, row 2 plus 2 row 1. Okay, we're trying to get rid of this, trying to make this 0. Obvious thing would be to times this by 2 and to add. And this is what you get. And row 3 minus 4r1, okay, and this is what you get. Row 4 plus 8 row 1, okay, and this is what you get. And row 5 minus 16r1, and this is what you get after, making this into a echelon. And then you do the same with the second column and the rest of it. And this is what you end up with. No, not yet. Not yet. And this is what you end up with. So what is this? A, B, C, D, E. E is minus 2 over H. So 24E is minus 2 over H. So E will be 1 over 12H. And then you can do back substitution and you get the values for all the rest. Is that clear? And this is the answer you get from the last row, from the fourth row, from the third row, from the second row, and eventually from the first row, giving your values as this. Whatever you put, now this is based on the A that was defined earlier. Now on the whiteboard, I have done it the other way around. On the whiteboard, my A is actually my E and my B is actually my D. So wherever you put your A, the values that you get will not change the whole thing. Meaning that after you've solved all this, this is what you get. F prime x is 1 over 12h, and this is the equation. So this is what the derivative of f at x would be based on 5 equal points, and these 5 equal points are x minus h, x plus h, and x plus 2h. Okay, what happened to C? C is actually 0. Okay, so you get C as 0. Is that clear? Is that clear, class?
Yes, doctor.
Can you see my slides?
We see the board.
Just now you couldn't see my slides when I was showing you.
No, we were seeing.
You were seeing the slides. Okay. All right. Now let's go back to the camera. Okay. Now, was it difficult?
It was
Was it
okay.
difficult? It's a bit messy. It's a bit tedious, but is it difficult?
Not much. It's
No,
okay.
it's just a matter of equations, a matter of equating left to the right and solving for A, B, solving for your variables. It does not matter what you call your variables. You can call them A, B, C, D, E, or you can call them P, Q, R, S, T, U, V. As long as you solve for it, it does not matter how you put the order, but you have to be systematic. Okay? Now, in your questions, in your tutorials, in your tests, and even in your revision papers, you are given many different ways of doing this. Okay, I hope you will try out all your tutorials and your revision paper so that you are able to answer the questions in the test. Okay, any questions so far? Why is it equal to 1 for the second equation? Okay, I'll get back to that. So the difference between on the board and in the slides will still result in the same final. Yes, it would be because of my arrangement, that's all. In the notes, the arrangement is x minus 2h, which I have put as A here. On my whiteboard, the arrangement was I started with x plus 2h. Okay, so it does not matter. Eventually, you should get this same thing. Okay, does that answer your question, Shanwei? Okay, now Gabriel Lim, y is equal to 1 for the second equation. Okay, would anyone like to try and answer this question?
Yes.
Okay, answer
So
it.
f prime x is equal to 5 terms here, which are equation of plus, and we are trying to equal left hand to the right hand. So f prime x is in left hand, and our f prime x in right hand is in our second term. And so the coefficient should be 1 with the hash, so we can equal these two together. And then the rest of the pluses like fx and hash square over 2 factorial and all of those should be 0, so we can make both of the sides to be equal to each other.
Okay, does that answer your question, Gabriel Lim? Or would you like me to explain to you? Okay, good. Okay, he understood. Great. Any other questions? You can also find higher derivatives. How do you find higher derivatives? You can find f d2f dx squared or d3f dx cubed or d4x dx to the power of 4. And how do you do that? Again, using the same equation that we have, and depending on the number of points you are using, but it is the equation which is equal to 1 that you need to think of. Okay, if you are looking for d2f dx squared, then it is that part which will be 1. Okay, going back to our same equation, all right, that we were working with, just look at your notes and you tell me if we are using the same points, okay, the same 5 points, but we want to find f3x, that means d3f dx cubed. Which equation would be 1?
Eight a plus b minus d minus 8a would be 1.
Yeah, okay. Don't forget your h cubed over 3 factorial or h cubed over 6. Okay, if you forget that, your answers will be wrong. The reason why we can forget that in the others is because it's 0. Okay, because when you bring the h cubed over 6 to the right hand side, and if the right hand side is 0, then that becomes 0. But when it is 1, that value will remain. Is that clear, class?
Yes, doctor.
Okay, so you've got enough exercise. Please try them on. And I'd like you to start with your tutorial. Okay, so far, any questions with your tutorial? Have you tried? Have you done all your tutorials? We should have about 4 or 5 tutorials with you now, right? Class? Sudden silence. Class? Okay, any problems with the tutorials? Have done till tutorial 5. Okay. Any questions so far? Let me have a look at tutorial 5. Oh, tutorial 5 is today's work actually, isn't it?
Tutorial
no,
6 is for today.
Tutorial 5 is on LU. So far so
tutorial
good.
5.
I had a few people sending me messages in the middle of the night asking me how to do these questions. So are you all right? LU and Gauss-Seidel and Jacobi methods? Any questions? Yeah. Okay. What? Yeah means what? Yeah means you got questions, or yeah means you're all right. Class. No problem. Okay, what about tutorial 4? Tutorial 4 is on Gaussian elimination. Oh, that should be easy. That should be no problem. What about some of the revision papers? Have you all finished with revision papers? Revision papers, any problem?
Doctor, just one thing. For the revision papers, will you be uploading the answers afterwards for like checking?
Yeah, maybe just before your final.
Okay.
Okay?
Okay.
I want you all to try the questions. I want you to try and do it.
Okay, doctor.
Nobody have tried doing the revision papers. How many revision papers have I actually put up? With today's work, it would be 3 revision papers already. Yeah, we've got 1, we have got 2, and today's is 3. I think there might be 2 more revision papers, okay? All right. Yeah, 3 including today's. Okay, any other questions? Anything you want to ask at all?
So, doctor, for the test on 3rd May, this topic would be covered also, right?
On the 3rd of May. When is the test on 3rd of May? Next week. Is it next week?
Yes.
Yes, today's work will be covered.
From the lecture 2, from lecture 2 to till this week.
I have, let me check. I can't remember, you know. What did I promise you all? Okay, it's not in your schedule, but it's actually somewhere. 3rd of May should be until numerical differentiation from root finding. Okay, so root finding, interpolation, linear algebra, Gaussian elimination methods, LU decomposition, Gauss-Seidel, Jacobi, and numerical differentiation. Your assignment is also due this week. Have you all started submitting your assignments?
Yes, doctor.
Let me see. I don't think I have seen anyone submitting assignments. Okay, 40 people have submitted. Today is the last day. In fact,
Doctor, sorry, I forgot to press the submit assignment button.
you what?
I forgot to press the submit assignment button. It was
You
in the bottom.
forgot to
I
press
overlooked.
the assignment send button.
Yeah,
Who is
it
that?
was Nabil. I just pressed right now. It was in the
Okay,
bottom, so
email
I
me.
overlooked.
Email.
Yeah, okay, doctor.
Okay. There are 8 more people. So Nabil is one of them. Who are the other 7? Who are the other 7? You don't tell me now. When it comes to marking the assignment, I will not I don't find your assignment, I'll just give you a 0. I will not even bother asking for it anymore. Who have not submitted their assignments? It was due this morning. Okay, I can tell who has not submitted by just looking at it then. Do you want me to call out your name? It does not matter if you submitted late as long as you submit. If you forget, if you had forgotten to press submit, you just, I think there is some leeway. The assignment, there is a grace period, isn't there? Okay, Yusuf Muhammad, are you here? Yusuf Muhammad, are you in class? Yusuf Muhammad, are you in class?
Not in the class, doctor.
No, he's not in class. I'm going to try checking again. Yusuf Muhammad, you're not in class. Okay, well, he's not submitted. If you are not interested in helping yourself, then there's nothing I can do. Mirzad, are you here?
Yes, doctor.
Have you submitted, Mirzad?
I haven't submitted yet.
Why? Were you aware that you need to submit today?
I
Okay,
was aware, yeah.
you are aware. Let me just remind you 10%. That assignment is 10%. And 10% can mean the difference between a pass and a fail. It can also mean the difference between an A and a B. Now, you are all in 3rd year. You are not interested in passing your papers only. You are interested in getting an A. If you don't submit your assignment, there's nothing I can do to help. All right? You know who you are. Anis Alina,
Yes, yeah, doctor. I think I forgot to click on the
Click the
submit
button.
assignment. Yep.
Okay. All right. If you can't still click, then you just email me.
All right, doctor. Thank you.
Shabil, you are 1 hour too late. I think you have submitted, but why does it say 1 hour 2 minutes late? I think because of the grace period. Shabil, you all right? Have you submitted? Excuse me. Shabil, not in class? Shabil? Tarin? 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 I thought you're in class, Tarin. Tarin? Where are you, Tarin? Okay, he's just left his computer on and gone to watch a movie, I suppose. Zheng Yi, you're okay. It just says you're late. I think you've submitted. Amir Yusuf, it says draft, not submitted. I think because you forgot to press the button. Rafi as well. Yue, Go Yue, and Huang Yifei. Okay, I think it's just a matter of pressing the button. Let me see if I can see your... It says draft, but I should be able to see your assignment. Oh, it's taking so long to download. Okay, it should be okay. Any questions? Any questions, class? Okay, if there are no questions, I think we can end here. Give me some time to mark your assignment as well as your test. Your test results should come before your assignment results. Give me another few days. Like I said, I've only marked 2 questions. It may mean a few more days before I'm done with it. All right? But from what I've seen, those who had actually done did quite well. But there were some of you who did not do the part B. You know, when you were looking for the secant method, the approximation using secant method or the Newton-Raphson, you did the first part. You find the answers, but you did not find the error. There were a few of you like that. So you just did the A part, but not the B part. Okay, so, and some of you did not round up to 3 decimal point, round up or round down to 3 decimal point. So apart from that, most of you have done okay, considering that, you know, it's your first written test. Okay, any questions? Anything you want to ask about assignment or tests and future tests before I go?
Doctor, so the next test would be same like the previous one, right?
It would be basically the same, but it might not be as long as the previous test.
Okay.
Not as many questions.
Okay, doctor.
All right. Okay. Anything else? And you all usually want to know when I start the test, right? Okay. Let me see if I can find it. Okay, for the next test, it will be open by about 1 p.m. Okay, it will open at about 1 p.m. It will close at about 5 p.m. Okay, so those of you who are not in Malaysia, please be aware of the time difference. Who's not in Malaysia? I know Tarin is not. Who else is not in Malaysia? Nabil, are you in Malaysia?
Yes, doctor.
Mirzad, are you in Malaysia?
Yes, I am in Malaysia.
Shahnil, are you in Malaysia?
No, doctor. I'm in India.
You're in India. So time difference, is it all right for you?
Yeah, it's fine. It's 2.5 hours, so yeah, it's fine.
Okay. Mara, are you in Malaysia?
Yes, doctor, I'm in Malaysia. But doctor, I want to ask for a favor. If possible, can you make the duration of the exam for like longer time? Because exactly that time from 3rd May, we have to do our monitoring session for FYP. If possible, if we can have like longer
You want
time.
to open it for a longer period?
Yes.
Okay, I will. Okay, I'll do that. Okay.
Thank you, doctor.
Maybe like the last time, is that all right? I think the last time I opened at 10 o'clock in the morning.
Yes.
Okay. Any more requests? The
Doctor,
time allocated is 1 hour and 15 minutes. The 15 minutes is just grace period for you to submit. All right? And there are only about 3 questions, I think. Okay.
Doctor, today's attendance, you have actually shared the editing link, so yeah, we're not able to take our attendance.
Oh, I did not. Okay, okay, let me see. If I... Okay, I will see what I can do. I will check the attendance. I see. It's all right, not to worry. Let me see if I can open this file. Okay, it's all right. I've got the date, so I can look at it. Okay, not to worry, class. Anything else? Anything else, class? Okay, if there is nothing else, I will. Yeah? Anything else? Tarin, I was talking to you just now, but you disappeared. Now you're asking me a question, the same question that your friend has answered. Can we use drawing pad to answer and submit it as one big image? No, I think it's best if you write on your paper. Okay? Yi Chong, just write on your paper. I prefer for you to submit one question at a time. Nabil, Tarin, and the rest of you, the exam is 75 minutes, which include 15 minutes grace period for you to submit. Okay, if there's nothing else, I will stop the class here now. I will end the class here. And I will see you, well, the 5th of May is your test. And after that, is it 12th of May, do we have class? When is Raya? When is Eid? Does anyone know? Hello? Silent?
It should be above 10 May.
Hang on, 12th of May. Oh, you're... Okay, it's mid-semester break, isn't it? You have a test on the 3rd of May and and a review on the 10th of May. Okay, but on the 17th is your break. Okay, so not a problem. You're in a break anyway, so there's no problem of me giving you a test during Hari Raya. Okay, so if there's nothing else, I will end the class today. Okay, bye everyone. I'll see you soon. Okay.
Thank you, Doctor.
Thank you, Doctor.
Thank you. Bye.